Hey, good morning, everyone. So, in today sessions, we are going to talk about a very brief talk about the performance testing. Here we discuss that's what is a need of a performance testing. Then we'll discuss that some type of performance testing. Okay, and then some basic concepts, some basic terminology which we uses in our day-to-day performance testing or load testings that we are going to understand those basic concepts. Then we'll understand that some tools what we can use for the load testing. Okay, and yeah, at last some the conclusions. So okay, so without delay, let's start it. Okay, so okay. So here I have divided just very high level. I have divided it to two parts. So the first is basics of performance testing. We'll understand, okay, and why it is needed. Okay, then I will understand the different tools and technologies. Okay, that's a very short slides what I have prepared for that. Okay, then the next slides I'm going to this in the next videos I'm going to more talk about the one of the very particular tool that is a guideline using Scala. Okay, how we can use to do our load testing. Okay, so now we'll understand why performance testing is needed. Okay, so the first things come into our mind, that's why do we need the load testings? Because anyway my code is working fine or dev machines on a staging environment, right? So why do we need it all? So first thing we need to understand very clearly that each and every application has its limits, and when as a developers when we design our applications, when we write our code, we should understand that what is the limitation of this applications. Okay, what is the bottleneck? Okay, and okay when the number of users will increase, what could be the bottleneck for this company, which layer the bottleneck will be, how many users it will be able to serve, that we need to understand clearly. Okay, so we need to agree that we need to understand the limit of our applications, and we know that each and everything have its own limitations, right? So if you understand the limitations, okay, we'll able to resolve the problems as very quickly. Okay, so that's why I'm saying we need to identify our pain points of the applications. Okay, next I'd like to discuss that when should we start our load testing. Okay, because that is also a matter of discussions that whether it should start from the very scratch when we are initiating the developments from the scratch, or after completion of the features then we should start. So what I feel that's start a performance study as soon as possible. Okay, not very starting a very from scratch only when you are just understanding the requirements, and when you started the development only for your project. But precisely if you say that you start after 2 3 sprint cycles, when you, some couple of features has been already be in the release and the productions and the people have started using. Okay, so that's the ideal time what I'll feel, and that time maybe you can run some loads, and you can find out the pinpoints of the bottlenecks for your applications, and that in initial phase the number of users will be also very less. So if any problems also comes, it's not going to impact your business, because you have very less number of users, and that time only you can identify the issues. Okay, and the issue can be your application, maybe the response type from the database, or maybe maybe it's require more memory, it's require caching things. Okay, or maybe you need to add more parts. Okay, no more cores we need to use, or it could be infrastructure issue, it could be the database performance issues, or it could be the and at the code level maybe you need to tune. So maybe the tuning could be required at the database levels or infrastructure levels. It could be anything. Okay, so at least we can identify as much as early as possible. The next slides is we'll now this slides we are going to understand different type of performance testing. So the first type of performance testing is a kind of load testing. Here we'll have some number of users, okay, will calculate, and that generally we do the calculation based on maybe we just estimate, okay, x number of users, okay, daily will be daily will land to our applications, okay. So that load will be handled throughout the day. Suppose that I am expecting 10,000 users in 10 hours they will log in, okay. So we can distribute, okay, in 10 hours the 10,000 of users will be created, and they will keep on accessing our application. So like that we can simulate such type of scenarios. Second is stress testing. Okay, so stress testing in that will just what we do, we just check at a certain points this load will getting increased, then it's going down. Okay, so we need to analyze whether at a certain points whether our application is going to handle that those many number of users or not. Okay, so okay, for a shorter duration only the number of users is getting increased. So how your application is behaving in that scenarios, that we need to we analyze in the stress testing. Okay, then we have a capacity testing and scalability testing is there. Okay, so we need to identify that our breakpoints when your when number of users get increased, and right. So and what means what is the capacity of a testing, maybe the 10,000 users, that is the peak. And if it is going up, and the lot of memory usage, CPU usage is happening, how your application is behaving. Okay, and if it is a lot of users, then how your whether the system is auto scaling or is not, whether it's a okay auto scaling feature is done, feature is there is not, means one more pod will be created, server will be created, and automatically all the services will be deployed and it's going to start serving the request. So those type of things, whether application have a such type of features or not, that we need to that we learns in this scalability and capacity testings. Volume testings is a kind of we analyze whether our application is able to handle huge data transactions or not. Take example of ticket bookings. Okay, in India we have right, so miss the millions of users do the bookings, so a lot of huge data transactions happens, whether so we need to analyze whether where our application is able to handle this huge transactions or not, data transactions. Okay, that we learn in the volume testings. Now endurance and availability testings, the last, that is we are going to analyze whether availability of our systems. Okay, we run a load test for a very long time, and we ensures that whether our system is available or not. Okay, like take example of Facebook, Skypes. We see that their availability is there almost 24/7, right? And billions of data processing the peoples are using, okay, across the board. Okay, so that same things we need to ensures that in our applications or websites that it is available all the time. Okay, 99.99% it is available. Okay, so what we do here, we run our load test for around 10 12 hours, 20 hours, 24, 1 or 2 days, just run it and check whether how the system is behaving. Okay, so this is what about the endurance or availability testing. Okay, guys, the next things what I'm going to discuss, some very basic things which if you are doing the load testings or if you are doing the performance testing, we are going to face these basic concepts, and I think without knowing these terms, I think it should be very difficult to the understands means to continue the load testing things. The first thing is the concurrent users. Okay, so when multiple users access a websites, right, but perform different activities, okay, at the same time, it's called a concurrent users. Okay, so concurrent user are not a simultaneous user, so that is also one terms came here, that is a simultaneous users, and the next lines we are going to understand what is a simultaneous user. So the best explanations I can refer is that concurrent users are connected to your applications and are requesting work at the same regular interval, but not all at once. So concurrent user means it's not like that they are simultaneously at one time they are requesting a same request. Okay, not means the multiple users have logged in, but they are requesting a different kind of request. So that is a kind of concurrent users. The next concept is a simultaneous users. So when multiple users access a website and they are performing the same actions, like suppose that 10,000 users, or maybe you can say 10,000 more, maybe you can say 1,000 users have logged in at the same time, and all are requesting the same login page, or all are requesting a card page at the same time. So that is called a simultaneous user. Next is a throughput. What is a throughput? Throughput in the sense how much data messages can be transferred from source to destination within a given time frame, right? So that is a throughput. Okay. So what is a request and okay, how much data is passing? Okay. So that is called a throughput. Okay, from source to destinations. Next, we are here what we are going to understand that the request and response breakdown, how the request. So when any user request make a request, okay, so how does this request travel across different layer, and then how the response will come by passing with the different layers, that we are going to understand here. Here we can see that maybe my pictorial is not very much clear, very much nice, or some nice, or very in a better form. But yeah, I wanted to try to make you understand. So the first you can see that first the user is there, okay, and and the users, and then through definitely internet you will access, and after internet the firewall is there, then our web server is there, okay, app servers and db servers, okay. This is a different multi-layer architecture is there. So when any user wants send a request, goes to the internet, firewalls and web servers and app servers, what happened? That it will last, it will go to the DB server, okay. It will fetch the record from the databases, and again the response come back to the user one. Total time, and that total time is called a response time, okay. So going so means when the user make a request, go to the internet firewall or the web server, and the DB servers will fetch the record, again passing back to the app and web, okay, and passing back to the user one is called a response time. So that is a response time. If another user 2, users 3 send a request for any transactions, and all three requests for all three users lie in between firewall to DB server, okay, called a concurrent users, means at the same times these all three users are calling to DB server is called a concurrent users, okay. If concurrent users are more, it can be so that's why, if number of concurrent users are more at the same times they are accessing the DB servers, then there is a possibility that our system will be the crash, okay. So testing with the simultaneous or concurrent user is a part of performance testing. So that's why it's a very necessary or that we should simulate with the simultaneous or concurrent users, okay, in the different working layer architectures, okay. Now so now one more concept is called latency. So when what are concurrent request and response time breakdown, such as connection times, DNS resolutions, first buffer time, etc. How request and response travel called a latency, means how much delay is happening when the request is going and the response is coming back, that is called a latency of our applications, okay. So yeah, this is what, so we'll go to the next, okay. Now this is a just I tried to explain in a more simple form, I think. So just take any shop, right? How if you want to do any shoppings, what you do generally, you'll go to the shop, by the name, right, will shop will have the same way if you are accessing the application, that will have some URL, okay, and that URL will be mapped with some IP address, that and then when you make a request, it will be the DNS, it will resolve the IP address, DNS lookup will be happen, okay. There also some delay will happen to identify which IP address it has to be hit, okay. Then request will be transferred to our servers, then server will start responding, and data will be sending back. So when that first data will receive, right, so that is called a first byte receptions, okay. So okay, so this is what, and one more things we need to identify that. So I think latency we have understood, right? This is what the delay things, okay, between sending request and getting response is called a latency. We need to also analyze that what would be the memory uses, okay, network uses and disk uses, okay, that also we need to identify here. Okay, here what I wanted to tell you that how to start, so because most of the times when we start a performance testing, there is always a dilemma that what should be our base exactly, and how will identify that how many concurrent users or simultaneous users, or maybe how many virtual users we should create to perform or load a performance testing, right? So, and which feature we should because one your application is there are a lot of features is there, right? And it will be not always true that all the users will access the help sections. They will, so they'll always access some very main features, right? So you suppose that any e-commerce application is there, right? So what users will do, he will first use a lot of times, most of the times they will use searching a product, adding a product into the cart, and doing the payment. So these are the main flow with the where the most of the users will access these features, rather than accessing a help sections or contact or all, right? So that we need to identify, okay. So so the thing is how we can identify the customer base, means how we'll come to know how many users are there. So actually there are some tools as there is actually how many register we some tools like New Relic is there, Datadog, or some any applicants performance monitoring tools are there. There are so many APM tools are there in the market. We can use those tools, and we can and when we can come to know that what is the user base, how many users are per day logging, okay, what is the peak timing, okay. So using that those APM tools we can come to know the we can have some rough estimations as the okay, how many virtual users we should create, or concurrent users we should be created, okay. So so this is what so yeah, so using that you can find out, means how many number using those applications. If or if you don't have any if your application is very much new, then you can see your competitors, that you can understand the markets, that how many users can be logged in, right? And if you right, and then you can have some rough estimation, right? Now which transaction you should mostly test it, okay. Just identify the what at all using that APM tool only you can identify which what at all feature is mostly used by the users, okay. And you can only pick those features only to do the load testing, okay. So take an example of this application is there where the home page, login, view, inbox, all those there, right? So we need to identify using that APM only we can identify which features are mostly used by the users, and just you can do the load testing for that only, okay. Okay, and this is also this the last things, the hardware thing, that is also most important things, right? So what it for these number of users, how much hardware support do we required, okay. The budget things also we need to understand, the routers, okay. How many pods, if you are in the clouds, how many pods, how many that RAM, how many cores of memories, CPUs you need to allocate, so that thing we need to understand, okay. Okay, so yeah, the same thing. I need to identify the hardware support budget according to routers, CPU, machines, clusters. What I think I've discussed with you before, and software architectures. I think the network bandwidth, firewall, load balancers, web servers. This is also these things are also most important things, right? The bandwidth, load balancers. These are the different layers in the software architectures, and each layers can cause a problem. So we need to tune, and we need to analyze each and every layers actually where in which layer the problem is causing. So when you are doing the performance testing, right? Okay, now this is also more very basic, very important concept. That is understand your active users, concurrent and virtual user. And the most of the times we get confused. What is a virtual users? What is a RPM? When should you use the RPM? When should be the concurrent virtual users? I feel sometimes it's very confusing things. Okay, so so what is the exact things? The goal of load testing is to find problems before they impact the users. Okay, very obvious things. Okay, and and simply doing the load testing is not going to add any value until unless it should be very realistic. It should simulate the real world applications. Okay, and if it is a and as much as it will be more similar or likely to the real world, we can identify the bottlenecks. We can identify the problems in our application. So as much as early. Okay, so so if you think actually it's the mostly what are all the things which affect our applications, that is a number of concurrent virtual users. Okay, is one of the most important factors, and ideally you could test as many as virtual users as you need. In practice, this may be too expensive because of load testing software is priced on the number of concurrent virtual users. So generally, this concurrent virtual is a main factor. But the problem is that most, if you are using any load testing tools, okay, and they are based on the clouds, will be charged based on the how many number of concurrent virtual users you are using, and maybe you have to pay the lot of price. So what is the workaround for that? That we'll see in the next slides. Okay. So figuring out how many concurrent users you need isn't always a very straightforward. For now, new sites that haven't at launched, anticipating real user traffic can be difficult. In this case, a soft launch, whether it's internal or maybe beta releases, is invaluable to learn actual user behavior and get some indication of traffic amount of users patterns. If that's not possible, looking at the comparable site can also be helpful. We can go with the other competitor sites and we can find out the how many number of users they are logging. Obviously, we won't get that many users because it's a new. But yeah, but if that much user base if you are creating, it's good. It's almost always better to have a setup that is initially overkill since okay, and that will get turn down resources as well. So whenever you don't need, you can just bring down all the resources. Okay, and that if you are using cloud, definitely auto scaling is there. So number of loads are not there, it automatically it will the whatever the extra spots and servers we are allocated, it will just deallocated. For existing site, you usually take existing traffic as a baseline using, I have told you so many APM tools are there, New Relic, this Datadogs. Okay, we can take a help from those APM tools and we can figure it out how many users, what is the user base. Okay, we'll have at least some rough estimate. So before continuing, we need to make an important differentiation. Okay, if you are testing a websites, then the concept of concurrent users, each with their own set of cookies and session data, is independent, is indeed applicable. Okay, but so if you are a websites concurrent users, say each concurrent users will have their own set of cookies and session data. But if you are testing a restless API, okay, REST API, right, the concept of concurrent users might not be applicable. Mostly there we uses this RPM uses or this either it is a request per minute or request per second we do. Okay, because one generally what happened at one virtual users or one concurrent users can make a number of multiple requests. Okay, so generally there is a concept of RPM or RPS only we consider while doing the load performance testing of REST services, or maybe gRPC also the same concept applicable. Okay, so so now we'll see that how do we calculate this. So here mostly we'll talk about this how can we test the backend. Okay, and how can we test the REST API or gRPC services here. So here we take means how we calculate our RPM or RPS. That the first thing is the number of concurrent users. Okay, how many concurrent users do we have? And so multiply the request per user per minute. Means if one user has logged in, so per minute how many requests he is making. So take example, I have logged in with my user ID. Okay, and it's not like that I will set ideal. I will make a one. If I'll click on the login, I will set ideal, right? I will go to the search page. So within 1 minute, I will go to the search. Okay, and then I will find some product. Again, I will click. Some page will come. I will click that hyperlink. So at least two, okay, and some again another page will come. Here I'm doing the backend testing. Just I'm giving you. I will get some different request and response I'm going to get. Okay, so I'm going to call different APIs within that within a single minute. Okay, so that is a how many requests I am making in a single minute. So the calculation is concurrent users multiply the request per user per minute. That is a total RPM. Okay, so example is if you run a load test with a 10,000 virtual users and each making a request every 20 seconds. Okay, then it means that three requests I am making in a single minute. Okay, it means that in a 1 minute 30,000 requests are going. Okay, or maybe if you so that is RPM, and if you divide that RPM into RPS, it will become 500 requests per second. Okay, so if you go any tools, right, you will find out that even though if it is a JMeter or Gatlin, if you are using Scala, you will find out some you have to do. When you are setting up the simulation, right, that there we need to specify the RPM or RPS. We need to specify, right, how many requests per second. Throttling is there, how you can control the request. Okay, anyway, that we'll discuss in the next videos. Okay, here here you can see I've given a three. Suppose that I need a 30,000 requests per minute, and I told you that these cloud-based companies, they will charge based on the number of users. Okay, so number of virtual users, right? So here different ways, because your my target is 30,000 RPM. Okay, so either you can create a 10,000 users and three requests per minute, and then you can achieve your 30,000. Else you can create a 5,000 and six requests per minute, right? And then it can be a 30,000. So these are the different combination. Using that we can achieve our 30,000 RPM. Okay, so considering the cat cost is often proportional to the number of concurrent users, that already I've discussed. So you can use any of this combination, but the question is whether just to save a money with this 10 into 3,000, the last one, right? Will it really simulate our real scenario? That is also a question. So, okay, so at least not that only we are going to discuss here. So let's return to our example with 30,000 requests per minute. If you identify bottleneck with 5,000 virtual users at 6 requests per second, it is unlikely that this is a false positive. Chances are you will also see a bottleneck when testing 10,000 virtual users at 3 requests per second. On the other hand, if testing 5,000 virtual users at 6 requests per second doesn't identify any bottleneck, right, you might have a false negative. Testing with 10,000 virtual users at 3 requests per second may reveal that you do have a bottleneck after all. So these are the common reasons you will see false negative. Storing, here we are going to discuss what could be the common reason of false negative. Maybe storing server side data per user sessions. This is almost always the case with e-commerce and web apps. This means that fewer concurrent user equals to less memory uses, and less memory uses equal to less bottlenecks. Use of some caching mechanisms. This means fewer unique users, more cache hits and more cache. So what we can do in the conclusions that we have given the 4 or 5 combinations. At least we can take a 2 or 3 and we can check it out. Okay, we can 2 or 3 combination we can take and we can check it out. We can use those combination and we can check to we can will be able to identify the bottlenecks here. Okay. Here we have a different tools. See, there are so many tools are there in the market for the performance testing, and these are the tools which I like, which I prefer most. The JMeter, I think, is the most of the our engineers uses JMeter. Okay, and the second one is a Gatling. This tools which I am using, and this is a good tools which the Gatling. We can use this that support here we can write code as well, and this supports Java, Scala, and I think I think Python and JavaScript also it does supports. Okay, So you can use any of the scripting language and you can write our load test scripts. Locust is there, K6 is there. I think K6 uses some JavaScript code. Okay, so these are the best tools what in the industry so you can use, and these are the free also. Free and professional both versions comes for the Gatling. Okay, so you can, based on your needs, you can use. Okay. Now, this is, I think already I've discussed these things. Means how many real users do you really have? Okay. I often hear the companies that want to render later, how load test with millions of virtual users. Okay. So, the same thing I think already I've discussed that you can use the APM tools and you can identify how many users do you have. Okay. And you can find out our code base. Means how many exact users do you really require using those APM tools. So I think that's it. What I wanted to discuss on this basics of performance testing. Okay. In next sessions, we are very specifically we are going to talk about the one of the you can say the good tool or best tools for the performance testing, that is a Gatling. And I am going to use Scala as a scripting language for to writing our test cases. So in the next videos we are again going to meet and we are going to write some basic script about the load testing. So thank you very much, guys. If you liked my videos, please like and subscribe this video. Thank you very much.